For this problem, we want to be able to find the integral of that function from -4 to 2, and the problem gives us the graph of f of x along with the area underneath the curve at each point. Now what we want to do is that we want to appeal to property of integrals before we even do anything. What I mean is that an integral can be split across across addition and subtraction, just like how you did with the limit. Meaning we split this integral into f of x dx plus the integral from -4 to 2, 2x dx plus the integral from -4 to 2 of 1 dx. Make notes that in each one of these integral, the limit of integration, the -4 to 2, stays the same, nothing changed there. And in each one of these integral, there is an accompanying term of dx. More on the property of integrals can be found in the note posted on Moodle. So please go back in there and look through the notes if you have any question on any of the property. You can add and subtract, you can take out a constant, you can change limit of integration, so on and so forth. Please look through the notes for that. Now, what this amounts to is asking, okay, what is the area given by f of x? What is the area, well, given by 2x? Well, we can take out the 2 because it's a constant and we just worry about x. Plus, well, that's just a constant. And up until now, the only way for us to find area is to be able to find the graph. Luckily, in this case, the graph of f of x has already been given to us. It's right there. We just need to add up each term, but we'll talk more about that later. Let's try to find the graph of just x from -4 to 2. Well, the graph of just x, so that's 1, 2, 3, 1, 2, 3, 4. And this is just x, so go up by 1, go down by 1, connect the dot. And then what do we have as the area underneath the curve? In this case, we end at 2. In this case, we end at -4. So these triangles give us the area underneath the curve. Here, 1 is just a constant function. At 1, it's just a straight line across, and from -4 to 2, that's our area. So with that in mind, that's all we need. We know all of the areas. The area of f of x is going to be 3. That's going to account for the part b, the one that's on top of the x-axis, minus 3. That's going to be part A, and then minus 3 again. So this right there, that's B. That's right there, that's A. That's right there, is C. Plus 2 times the area of this function, which is going to be 1/2. The right triangle have a base of 2 and the height of 2, plus the left triangle have a base of 4, So 1/2 base of 4. Height is also 4. But we also have to note that that have to be a minus because it's underneath the x-axis. And then the final one, simple enough. This is just a length of 6. And the height of 1, so it's just 6 times 1. So we add everything up. Minus 3, so that's a minus 3. 2, this is a... This itself is 2. This itself is 2 and 4, which is 8. And then there's another 2. So all in all, that's going to be minus 6 times 2, so minus 12, plus 6. That's going to be minus 15 plus 6. That's going to be a minus 9.